Okay, so before we go through the details, I also want to provide you with some basic information about what makes deep learning work nowadays. So we all know that deep learning models have been achieving lots of success in many areas in both academia as well as in the industry. And many companies are investing for their future into AI, right? Into self-driving cars, into many other areas, with deep learning models. And then what really makes deep learning model works nowadays? And so the success of deep learning nowadays actually rely on three main key parts. So the first part is about the hardware, the GPU, the chips, the high-performance computing, as well as cloud computing. We have to rely on many of the hardware for learning and training the models for us, which should be much more efficient than classic CPU-based learning methods or hardware. Besides the hardware, we also rely on some of the data, right? Because deep learning model rely on the data inputs. Compared with the classical machine learning, the machine learning can still utilize some domain knowledge from domain experts. But for deep learning, we just rely on the data for the feature learning. We don't have the feature extraction step anymore. We rely on the feature learning, right, from data instead. Therefore, you see, we need to have a large enough data set for training the model, right? But the good news is that nowadays we have big data generated from many domains, areas, so we can provide the models with large enough data for training them, right? So the big data will make the deep learning much more successful nowadays. Also, the success of deep learning also relies on the deep model architectures, because classical machine learning models, when we build a very deep architecture, then the model will not work very well. And nowadays, we have many new solutions to make the model can work, like with the residual learning techniques we will show later. Now here in the bottom, we show a very deep model, with multiple layers for the CM model. Between the layers, we have some highways, right, which are called residual learning. We'll discuss this later in the following lectures. What are the highways connecting among the layers and why they can make the deep learning more successful than just stacking these layers together with each other. Okay, so these three factors will make the deep learning works nowadays. And we will provide you with some background knowledge for the GPU computational power. If you have the GPU installed on your computer, then you can try the GPUs for training deep learning models. You can see it will be much more efficient than the classical CPU-based learning. And in this page, we will show you the GPUs provided by NVIDIA, right, in recent years. When I work on this area, on this domain, the GeForce GTX 1080 Ti is still the most powerful GPU. So I have been purchased for this 1080 Ti, this GPU in 2017. In that year, this GPU is very powerful. However, nowadays you can compare this GPU with the latest GPU like RTX A60000. You can see the scores achieved by GPUs, right? Nowadays, the performance of new GPU is about 10 times more powerful than a 1080 Ti GPU already. So from the proposal of this 1080 Ti GPU until today, we only about 4 or 5 years, right? And you can see the progress or the development of the GPU in this industry in the recent years. The GPU can provide deep learning with the sufficient computational power to train very complex models. So if you are building a very complex model with a large data set, you may consider to try to play with GPUs to train the models in your projects. And besides hardware and GPUs as physical foundations, the big data also helps a lot for the success of deep learning. Big data is more like the fuel of deep learning, right? It provides a model with sufficient data inputs for training or for learning the model architecture. The good news is that the data size is also growing very fast, almost exponentially nowadays in many of the domains. And in this page, we show you the estimated size of data generated globally, in recent years from all the industry. And you can see the size in the zettabytes. It's a very large unit, right? And we'll see the growing trend in the past year as well as the estimated size for the future growth. And according to this report, by 2025, the size of data generated globally will reach about 175 zettabytes. So it's a very large data set, and it can provide deep learning models with sufficient fuel for training them. And in the left-hand side, we will provide you with some statistical numbers for data generated in almost every minute. So in 1 minute, there will be about more than 6,000 TB data generated by the users. In every minute, we will also have more than 84,000 Instagram photos uploaded to the sites. in 1 minute, and we also have more than 5 million of searches in Google, and more than 300,000 Skype calls, as well as more than 185 million of emails sent. So you can see that people are generating data almost every second, every minute, and the data amount in every minute is not enough for training the models. So big data can provide a fuel for us to train the models. Then we also rely on some deep algorithms. So in recent years, we have been seeing lots of deep learning algorithms proposed, and we also see many of different algorithm toolkits provided by both industry and academia. So we can see different architectures of models which can make the deep learning more successful, and we also see different toolkits like PyTorch, TensorFlow proposed by both Facebook and Google, and they allow the researchers to implement new algorithms much more effectively and efficiently. And on the left-hand side, we show the general architecture of many models, about deep learning. And for many of them, we will cover them in the lectures. And so you can also take a look at their architecture to know what they work and how they work actually. It can serve as a roadmap for you to do research about this area if you plan to implement some of the baseline methods about deep learning. So you may wonder how complex are the deep learning models nowadays. In this page, we show you the number of parameters incorporated in the deep learning models proposed in recent years by many of the industry companies. So if you can see, the bottom, the x-axis denoting the years of the models proposed, and this y-axis denoting the number of parameters incorporated in these models to be learned. So according to this report, the latest model we have been seeing, which is also very large, is actually the Switch C from Google. The number of parameters incorporated in this model is more than 1.6 trillion. It's a very large number, right? And you may also wonder how large is this model. We also provide you with a comparison with human brains. So according to the biological study, the human brain has more than 100 billion of neurons. And among the neurons, we have some connection, which is called synapses. We have more than 1,000 trillion synapses. So for the models we have nowadays, we have more than 1.6 trillion of these parameters, which is more like the connections among the neurons. So the trillion, this unit is comparable to the 100 trillion of synapses in the human brain already. And for the future years, I estimate this number will keep growing very fast. Hopefully, in the coming years, we will be able to see some models which is larger enough, even larger than the human brain, the number of synapses in our brains. So you can see the models we have in the deep learning domain is growing more and more complex. And we have more and more parameters to be learned. And also with the help of both the GPUs, big data, and deep model architectures, we can build more complex models which can achieve very powerful functions as well as very good performance in many of the tasks. In this course, we will show some of them for you, about what can deep learning do and what are the model architectures about them. Okay, so these are the key factors which makes the deep learning model successful nowadays in terms of both the GPUs, hardware, the big data, as well as deep model architectures. We also provide with this diagram about complexity of the deep learning models we are using nowadays in the industry. So you can see, this domain is growing very fast. The models we proposed 2 or 3 years ago is already very old. And normally we have to keep learning something new. Okay, so that's it for the key factors which makes deep learning more successful. Next, we'll move to the artificial neurons we can use for building very complex deep learning models.